Alright, so today we're going to learn how to dilate points and triangles. So right now, we have this triangle, and we're going to dilate it by a factor of 2. Now, if I'm dilating by the origin, dilations are easy. All I'm going to do is multiply by the dilation factor. In this case, it's 2. Notice that 2, 2. If I double the points 2, 2 by 2, it's going to be at 4, 4. So 2, 2 times 2 is 4, 4. I got that point right there. 10, 2. 10 times 2 is 20. 2, 2 is 4. So if I dilate 10, 2 from the origin, it's going to go to 24. And 10, negative 4 is going to go to 20, negative 8. And notice I end up with this triangle. Now, anytime I dilate, my previous shape is going to be a different size from my original shape. Well, new shape is going to change from the previous shape. If the factor is 2, then my new shape is going to be twice the length, twice the height. All my line segments are going to be double because the dilation factor is 2. So I'm going to move this triangle over here. So anyway, this blue triangle dilated from the origin is going to be over here. It's going to be over here. Now what I want you to notice is that all my distances from that dilation point or dilation center is going to be doubled because the dilation factor. So let's take a look. This distance right here is going to double to that distance over there. This point is this distance, and it's going to get doubled to that distance. So far, so good?
Yes, sir.
All right. So let's get rid of that.
I gotta go to the office.
All right. Goodbye.
Bye.
So
Bro, watch.
let's go over here. Let's move that out the way for now. So this problem didn't ask us to dilate from the center. It said dilate about the point 4, negative 2. So what I'm going to do now is I'm going to look at everyone's distance from 4, negative 2, not from the origin. So in this case, I can't just double these numbers, right? 10, 4, 10, negative 4 is 10, whoops, it's 10, 4 away from the origin. It's not 10, 4 away from 4, 2. From the origin, it was 10, 4, so I could just double 10, 4 to 28 to be double the distance. However, I want the distance from, that's the way, 4, negative 2. If I look here, this is 6, 2. 10, 4 is 6, 2 away from my dilation center. If I'm dilating by a factor of 2, I'm going to double that. So instead of over 6 down 2, I'm going to double it to 12, 4 from the center. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 1, 2, 3, 4. So far, so good?
Yeah.
So I'm going to end up with that point right there. So instead of 6, 2, I'm going 12, 4. Now, we have graph paper. It's easy to see on graph paper. If I didn't have graph paper and I said, hey, dilate 10, 4 by a factor of 2 around 4, negative 2, I could do what Noah did and I could just subtract. Negative 4 minus negative 2, isn't that negative 2? That means negative 4 is 2 lower than negative 2. And 10 minus 4 is 6. So 10 is 6 more than 4. So I know to go from here to here, it's 6 in the x direction, negative 2 in the y direction. So I'm just going to double those numbers, and instead of over 6, it's over 12. 4 plus 2 6s, and negative 2 minus 2 2s, and then I would have my my coordinates. So 4 plus 2 6s, 4 plus 12. I know this point has to be 16. And negative 2 minus 2 2s, right, is going to be negative 6. So I know this is 16, negative 6. So even without the benefit of graph paper, you should be able to dilate points from other points. But, okay, let's look at the other points. 2, 2. How do I get from 4, negative 2 to 2, 2? How much do I have to move in the x direction?
Left 2.
Left 2, 1, 2,
Up 4.
and up 4, correct. So I'm going back 2, and I'm going up 4. So from 4, negative 2, I'm going back 2 and up 4. Dilation factor is 2. Let's double that. So instead of back 2, I'm going to go back 1, 2, 3, 4. And instead of up 4, I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to end up over here. So far, so good?
Yes.
All right. And last one, you know what? Let me move these out the way. Oops. Let me keep that there. Let me move this out the way to clean this up. So now I want to get to 10, 2. How do I get from 4, negative 2 all the way to 10, 2? How much am I going over?
It's 6 over.
Yep. 6, 4. So instead of going over 6 and up 4, I'm going to go
Over 12 and up 8.
Yep, over 12 and up 8. 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have a point right there. Let me move this out the way. So do we see 6, 8 that we're going to be over here? Oops. You see that we're going to be over here? So do we see that if I dilate this blue triangle about 4, negative 2, do we see that we have this red triangle?
Yes.
Now, I want you to take a look at the original triangle that we had. When I dilated about the origin, didn't 2, 2 become 4, 4? So the green dots, the green dots are when I dilated by the origin, here, here, here. The red dots are when I dilated by this point, 4, negative 2. Do we see that the red triangle and the green triangle are the exact same size?
Yes.
So when I dilate by a factor of 2, all of my lengths are going to double. This leg, and the hypotenuse are all twice the size. Let me take my original triangle. If I put that there, it's over here. I'm going to pause here and move this from here. Notice hypotenuse is twice the size. This leg and here, start here. Notice twice the size. And here, move over from there. Notice that these two triangles are exactly twice the height and length of this triangle. If this was dilating by a factor of 3, it would be 3 times the length. Now, where you dilate from, as you can see, doesn't matter. So if I dilate from the origin, I'm over here. If I dilate by this point, I'm over here. If I dilate by a completely different point, it's the same exact triangle, it's just going to be in a different location. Make sense? Yeah. All right, so I'm going to post this for you guys could watch this video as often as you want, as well as the other classes. Any questions?
You're posting it on Teams?
I'm posting this on Teams, yes. All right? Anyway, hope that was helpful. Christian, you can pause.
Nah.